Hello, everyone, and welcome back. I'm going to take this video to talk about a debate that happens between the French philosopher Henri Bergson and Gaston Bachelard. Now, this video is building off of a previous video that I published on the debate that happens between Bergson and Einstein. And as you will see, hopefully, in the latter part of this video, the reason why the Bergson-Bachelard debate happened is because of Bergson's interpretation of Einstein's theory of relativity. So in many respects, you might want to go watch that video. If you haven't seen it already, it'll provide some more context for this discussion. But let's talk about some other cultural, historical influences that kind of shape the parameters and the context of the discussion. Now, we're talking early 20th century France, and without a doubt, probably the most important event, cultural, political event that happens in Europe in the early 20th century is the First World War. Now, the First World War, of course, starts in 1914 when the Austrian-Hungarian Empire invades Serbia. The reason why this is important is because the people that this story involves, let's start off with talking about Albert Einstein and Henri Bergson. Einstein is, of course, German. Now, he's also ethnically Jewish, which plays another important part of this story. But Einstein's German, and the First World War, after it ends, of course, the Central Powers, Germany, Austria-Hungary, and for the first part, Italy, Germany, Austria-Hungary, and the Ottoman Empire. Austria-Hungary collapses and the Ottoman Empire collapses at the end of the First World War. So most of the blame for the war occurring falls on Germany. And even as the war is happening, there starts to become this intellectual divide between German intellectuals, scientists, historians, philosophers on the one hand, and French and British and American scientists, philosophers, intellectuals on the other hand. So Einstein will have some of his biggest breakthroughs in his study of physics during the First World War. But let me back up a little bit. Einstein was, by the time that the First World War started, was very well known in Germany and throughout the intellectual circles in Europe. This is because in 1905, Einstein publishes his paper on the electrodynamics of moving bodies. And this paper provides the structure and the framework for what's referred to as special relativity. And it outlines some very important ideas, such as this idea of the relativity of time, time dilation, and disrupts the commonly understood definition of simultaneity, which we'll come back through. But it's really not until 1915 that Einstein is able to elaborate on these ideas and provide a coherent, inclusive theory, his general theory of relativity, in which he gives, starting off with a series of lectures at a German university, I can't remember which one, in 1915. So it's really not until 1915 that Einstein's able to work out a lot of these ideas. And of course, that's right smack in the middle of the First World War. When I say that there's a cultural divide, or that there's a growing divide between English and French and German intellectuals, I mean that in some cases, it gets very extreme. So, for example, in England during the First World War, there were restrictions about which Germans could be taught in English classrooms. And the flow of communication, of science communication throughout Europe basically stops with the beginning in 1914, with the beginning of the First World War. So although Einstein is developing these ideas, they largely go unnoticed, with the exception of a few people such as Arthur Eddington. It's not until after the war that Einstein starts to get his ideas out there. And this is some part of political move. The idea was that even though this catastrophic political event and the deaths of millions and millions of people had happened, that we want to bridge that gap by promoting this German scientist ideas that had the potential to revolutionize physics. And so Einstein goes on this sort of European tour. So World War I ends in 1918. It's in 1919 that Arthur Eddington, the English scientist that I mentioned before, would conduct some experiments that would provide some of the first empirical support for Einstein's theory, the empirical support being that light bends due to the gravitational field of the sun, that you can actually observe light bending. So with respect to France, there's some other cultural considerations to take into account. One is that one of the things you have to consider when talking about the reception of relativity in France is the idea that the specialization of sciences had not quite yet occurred. It had occurred in some areas. Physics was, of course, its own distinct area of study, but other disciplines, most notably psychology, was still taught under the general umbrella of philosophy. So by the time the early 20th century rolls around, you had people who were studying what we would now consider like psychology proper, who were still teaching within the philosophy department, because psychology in France had not yet broken away. I think it was only in the United States with like William James that was actually teaching like pure psychology classes, but different story for a different day. So you had some physicists like Poincare who was talking about things like, well, Poincare is very, very interesting. So there's this debate within the history of science about where exactly Einstein's intellectual influences are coming from. And Poincare is probably one of the prime culprits here. Poincare was talking about things such as time dilation and the results of the Michelson-Morley experiment a couple of years before Einstein was talking about it. So there's some debate about whether or not or how much Poincare influenced Einstein's thought. Poincare had identified that the time of clocks may not be identical to the time that we experience as human beings, and talked about the fact that there may be a distinction between the two, that we may experience things like, or not that we experience, but that there's time dilation and maybe differences in our definitions of simultaneity from person to person. So Einstein's idea wasn't radically new to people in France. The rub, which we'll talk about, comes about in the relationship really between physics and psychology, I think is where the breakdown happens, and between physics and biology. After World War I ends in 1918, like I said before, Einstein will kind of go on this tour of Europe talking about the ideas that are present in his special and general theory of relativity. One of the conversations that happens, and this happens several times. So as I explained in the previous video, Einstein and Bergson will have this famous meeting during the French Academy of Sciences, in which they'll kind of have this little back and forth debate about the meaning of relativity. But this discussion was happening even before Einstein made his visit to France. There were some French philosophers and physicists who were discussing these things. And the big topic of discussion was the physical meaning of two big ideas that come from the theory of relativity. The first is the understanding of simultaneity, and the second is what has come to be known as the twin paradox. So simultaneity, strictly speaking, Einstein kind of upends our understanding of what it means for an event or two events to happen simultaneously. Einstein upends what our common meaning of the idea that two events happen at the same time. He gives this example in his 1905 paper. Well, he doesn't give the specific example, but this example is taken from the equations he puts out there in his 1905 paper. So you have two observers. One is standing still on a platform, observer Y here, and the other is in a moving train. And we have these lightning strikes that take place. So you have the observer standing still and the observer on the train. And we have these lightning strikes that take place at points A and B. And they seemingly happen at the same time. And Einstein asked this question: what does it mean for these events to happen simultaneously? One of the implications of Einstein's theory of relativity is that because the person that is moving on the train is accelerating, is moving at a faster pace, that these two people will not experience this event at the same time, and that the person moving on the train will actually experience lightning strike at point A before they will experience lightning strike at point B. The implication of this is that both of these observers have a different time frame, have a different frame of reference in which they experience things temporally differently. This is the twin paradox. And there was a lively discussion that happens 1920, I think it was, the French Academy of Sciences, in which Livingston, I can't remember the gentleman's name, presents a paper on the twin paradox and the meaning of the twin paradox. The twin paradox, very simply put, you have two people. One person stays put, let's say stays put here on Earth. The other person hops in a spaceship and travels out away from Earth close to the speed of light, very high velocity, right? The paradox is that when the person who was on the spaceship comes back, they will roughly be the same age, and the person who had stayed put would have aged rapidly. Now, this is really strange, the idea of movement through time, and the idea that these two people would experience different times to the extent that one would age faster than the other. Now, the question that was raised, the debate that happens, is what does this mean physically? What does this mean? So in the example of the simultaneous events, an example of the person observing the lightning strike, this seems to imply that person Y and person X have two different time frames, that they experience things, temporally speaking, in different ways, and that each person has their own time. That's pretty crazy to think about. The twin paradox seems to suggest that this is true biologically speaking as well, that the person on the rocket ship would roughly stay the same age, and that the person that stayed on Earth would age physically. And so the debate was, were these ideas that Einstein was putting forward, were these ideas simply theoretical? That is to say, were these ideas simply a matter of mathematics, or did these ideas carry real-world implications? If you were to physically carry out the twin paradox, would the age difference actually occur? And when dealing with simultaneous events, what does this mean? That each individual person has a different reference frame, has a different temporal reference frame? Do they all experience time differently? And this is odd because it doesn't seem like we do. I mean, in our day-to-day life, most people have a general sense of time and the progression and movement of time that we all seem to share, right? If you have to be at work at 8 a.m., everyone at your job understands what that means, right? This is not an excuse that's going to get you out of being late. If you show up at 8:30 and you say, well, boss, everybody has a different reference, that's not something that flies in the day-to-day world, right? So as I said previously, a meeting at the Society of French Philosophers happened prior to the Bergson-Einstein debate. So the Bergson-Einstein debate happens in the early 20s, I think 1922. But even as early as 1911, you have this discussion about what Einstein's theory of special relativity means. So we have two quotes here, one from Langevin and the other from Brunswick. Sorry if I'm pronouncing those names wrong. But Langevin in the 1911 conference presents what he believes to be some of the physical implications of relativity. And this is what he says. The principle of relativity consists in admitting that even if other means, mechanical, biological, could be brought to a level of precision comparable to the first, measures of time and space made by optical and electromagnetic means, they would also furnish the same results, meaning that relativity has biological implications, not just mathematical implications. It is therefore necessary from the point of view of the principle of relativity that all the mechanical, electrical, optical, chemical, and biological processes employed for meaning time lead to concordant results. So what relativity has to say about time, and Langevin is really harping on that twin paradox, that the twin paradox, if it were carried out, would be physically true, biologically true. It would have biological implications. Brunswick says, he presents after Langevin and presents kind of a counterpoint, and this is where the discussion kind of starts. It still must be established that the life of the clockmaker is linked to the moment of the watch, and that biological or physical phenomena depend on physical phenomena that are used to measure time. You are not only one of the clockmakers linked to a clock, you are the maker of clocks. This is the idea that measured time, or the time of the clocks used in the experiments of relativity, is different and distinguishable from our time, because we are the ones we are not one of the clocks, as Brunswick says. We created the clocks. What the clocks are measuring is something distinct from us. And this is exactly where Bergson will pick up. In fact, this is what Bergson, the point that Bergson makes in his debate with Einstein. Bergson says, and this is from the 1922 debate, Bergson says, common sense believes in a single time, the time for all being and all things. Where does this belief come from? Each of us feels that we endure. This duration is the very flow, continuous and undivided, of our inner life. The time of our inner life is separate and distinct from the time that Einstein is physically measuring. It's separate and distinct because Bergson appeals to basic intuition. We all have a sense that our life, temporally speaking, moves in a certain direction. You were born, you had an early childhood, now maybe you're a young adult, an older adult. There's a certain direction evident there. You're getting older, right? And for Bergson, this is like just a basic, indisputable fact of existence. I mean, it was indisputable before Einstein. No one would really argue with that. But Einstein's objection here, which of course Bergson didn't like, Einstein says, quote, "But nothing in our consciousness allows for us to conclude the simultaneity of the events, for these are only mental constructions, logical beings. Thus, there is no time of the philosopher." The time that Bergson's talking about is merely a mental construction. There is only a psychological time different from the time of the physicist. The sort of time, the critique here is that Bergson's making an arbitrary distinction between measured and physical time, that there really is no difference. Bergson lays out his ideas about time over the course since this meeting. So Bergson has several books that deal with the subject of time. One of the first is one of his most famous books is Creation and Evolution. Bergson talks about his notion of duration there. Probably his most popular work on time is Duration and Simultaneity and Time and Free Will. In Time and Free Will, Bergson presents us with his basic understanding of time. And for Bergson, time can be condensed, is kind of centralized in this understanding of duration. And what Bergson means by duration is precisely what he's talking about in this previous quote. Duration is what we sense, our sense of time, our understanding of time that's derived from our lived experience. In Time and Free Will and Duration and Simultaneity, Bergson will draw this distinction between physical time on the one hand. Physical time, sometimes he'll call it measured time. This is the time that is talked about within the context of physics. And internal time, on the other hand, our internal psychological experience of time. And the question is, which sort of time is more fundamental? Which form of time is more basic? Which should we understand to be the foundation of our understanding of time? And for Bergson, this results. Bergson's argument is that it is internal time, and that internal time is defined and characterized by our experience of duration. But let's talk about this distinction. So with respect to physical time, this comes from Bergson's Time and Free Will. He says that, quote, time enters into the formula of mechanics, into the calculations of the astronomer, and even the physicist under the form of a quantity. So the time of physics, argues Bergson, is quantifiable, it's measurable, it's inherently mathematical. And the resulting problems that come from how we measure time are also mathematical. This leads Bergson to make the following remark: science cannot deal with time and motion except on condition of first eliminating the essential and qualitative element of time, duration, and the motion of mobility, mobility. So Bergson's not denying the enterprise of physics, or he's not even really objecting to what Einstein's saying scientifically. Bergson is just trying to draw people's attention to the fact that the sort of time that Einstein is talking about it's a confusion of terms, right? There's sort of a false similarity in the word time that we're using here, and that it's a mistake to treat the sort of time that Einstein's talking about as the sort of time that we physically experience, or that is evident to us. That the time of the physicist is an inherently mathematical time, and because it's inherently mathematical, it's rational, yes, it's logical, yes, but it is a construct, a mental construct. In other words, there's no basis, there's no reason to believe that it has a basis in reality. So for Bergson, the twin paradox might be interesting, but it's merely sort of a thought experiment that reveals to us something about measured time, and that if it were to be physically carried out, the aging process wouldn't happen. Internal time, argues Bergson, is real time. I'm using air quotes here because this distinction that Bergson makes, even within Bergson's thought, is a little bit arbitrary. Real time, there's only one real time, but right, the internal time, our sense of duration, our sense of temporal progress, this is what real time is based on. And Bergson says, with respect to internal time, distinct states of the external world give rise to states of consciousness which permeate one another, imperceptibly organize themselves into a whole. So we have all of these sort of discrete temporal experiences that, when taken together, form this whole. And you can think about this within the context of the narrative of your own life. We have all of these individual events that have happened to you over the course of your life, and you form those events into you as a person, right? If I were to ask you to write an essay about who you are, a major part of that essay would be you reflecting and interpreting on your past events or things that have happened to you in the past and making sense of those. And this is what Bergson says internal or psychological time is. The thing and the state are only artificially taken snapshots of the transition. This transition that is naturally experienced is duration itself. So we experience the ebb and flow of time, and taken as a whole, this is what Bergson means by duration, the transition of one moment into the next. We experience it not as individual discrete moments, but as a whole. There's several examples that Bergson gives to explain this. The first he uses in duration and simultaneity is this idea of the shooting star example. So Bergson says, imagine you're staring up at the night sky and you see a shooting star kind of move across the night sky. When you experience this, you could mathematically measure out each point that the star crosses, right? You could say it goes from point A to point B to point C to point D. But Bergson says if you want to understand the experience or your vision of the moving star as a whole, as a shooting star as a whole, you have to take all of those points in conjunction as one general moment. And that is what he means by duration. Another maybe helpful, I don't know if that last example was helpful, but another example would be that of music, right? Music and mathematics are intimately linked, and you can break down each note, and this is apparently, I am musically challenged, so maybe this is a bad example for me to elaborate on, but a song is composed of each individual musical note, but you don't listen to the single note and say, that was a beautiful song. You listen to the whole thing, the entire movement, right? So this is what Bergson understands to be as duration. And going back to the twin paradox, Bergson's argument is that, yes, measured time may transpire between one twin and another. In other words, he's not denying that the twin that leaves on the rocket ship may measure their time differently than the twin that stays on Earth. But Bergson's argument is that they would both experience the same duration, because that's just how the human brain is structured. They wouldn't experience time dilation. They wouldn't biologically age, right? Bachelard's disagreement with Bergson raises a larger question about the relationship between the new physics and philosophy. So Bergson's argument is a logical one, is a rational one that is predicated on the fundamental human experience of duration. Bachelard's argument, and Einstein, of course, fundamentally disagrees with that. And Einstein and Bergson have this entire falling out, but I talk about that in my other video if you're interested. Bachelard's approach is to take the science seriously. That's not to say that Bergson didn't take the science seriously, but to take the implications of the science seriously. And the rationale for this is because within Bachelard's thought, so you can view the corpus of Bachelard's writing can kind of be divided into distinct segments. Bachelard starts off his career writing about epistemology. He has a few works on time, the dialect of duration and the intuition of the instant that come after his works on epistemology. And he kind of ends his academic career writing about aesthetics, Things like the poetics of space, the psychoanalysis of fire are kind of phenomenological experience of these things. But at the heart of Bachelard's epistemology is the idea that science itself shapes and molds rational thought. And that rational thought, this is a stark departure from beginning in the Enlightenment with philosophers such as René Descartes, who's another Frenchman, right? Descartes' argument was that our knowledge of the world is predicated on these clear and distinct ideas, and that these clear and distinct ideas can be accessed through human intuition. That basically, the example I give when I teach Descartes is that you could go sit in a closet, think really hard about the world, and come to fundamental truths about reality, right? Part of these clear and distinct ideas, this goes back to Descartes' discourse, where he gives his famous "I think, therefore I am," right? He's trying to provide a foundation of knowledge. And for Descartes, the rationalist, the foundation of knowledge is our basic intuitions of the world, which reveal these truths. Bachelard says that with the development of modern science, that idea, that fundamental truth can be derived from intuition, is fundamentally wrong. And it's wrong because our scientific understanding of the world is oftentimes completely at odds with our basic intuitions of the world. There's a lot of examples of this, but the two big examples that Bachelard's dealing with is one, the Einstein's theory of relativity, and two, quantum mechanics, right? So one of the things that made Einstein so controversial is he upended our basic understanding of even fundamental concepts like the simultaneity of two events. What does it mean for two events to happen at the same time, right? Einstein, in his 1905 paper, demonstrated that simultaneity is not something that we can take for granted, and that there's no absolute sense of simultaneity. Quantum mechanics will do the same thing, but with concepts like space in place. What does it mean for an electron to be in a position? It's very easy to talk about position, acceleration, speed. It's very easy to talk about those things at the level of reality that we experience, right? If you're unfortunate enough to have received a speeding ticket, I mean, these sorts of things happen for some people on a regular basis, me mostly, right? These sorts of things happen on a regular basis. You can track not only the position of the car, the speed of the car, and you can even map out and have a very good idea of if the car is moving from point A to point B at a certain speed, not to give you flashbacks to high school math, right? But you could tell me if the car leaves at point A and is traveling 55 miles an hour, when exactly it'll arrive at point B, right? That's pretty cut and dry, basic stuff. It's way more difficult to do that with subatomic particles. The example that Bachelard will give that'll draw upon repeatedly, of course, is the electron, and of course he's being influenced by Heisenberg's uncertainty principle here, where you can give the position, where the position is indeterminate. It's just a range of probabilities rather than an exact location. So Bachelard says that, this is a quote from a book that he writes on scientific epistemology called The Philosophy of No. Scientific thought, therefore, furnishes a principle for the classification of philosophies and the study of the progress of reason. In other words, science is not beholden to philosophical reason. In fact, the inverse of that statement is true. Philosophical reason is beholden to the developments of science. So Bergson's enterprise of critiquing relativity based off of intuition for Bachelard is a fool's errand. It's a fool's errand because it's in the case where science contradicts our intuition, we shouldn't question science. We should be questioning our intuitions, and maybe it's our intuitions that which are incorrect. The two big influences, the two big scientific influences for this epistemological position, as I mentioned before, are relativity and what Bachelard calls microphysics. This is a antiquated term that was used in the early 20th century to refer to quantum mechanics. It hadn't quite gotten that label yet. It's the physics of microparticles, atomic, subatomic particles, right? What we call quantum mechanics today, but which I'll call microphysics, because that's the language that Bachelard uses. So with respect to relativity, Bachelard says that in the old physics, entities were assumed in order to measure their effects, whereas in the new physics, it is the very body of measurement that these assumptions are placed. When we talk about relativity, when we talk about things like time dilation, what Bachelard says is that we have to understand that it's not just our understanding of time that is changing, but it's also our fundamental understanding of reason itself that's changing, and that with relativity, things that were normally assumed or normally taken for granted have to be amended in the light of science, and that with relativity, that relativity assumes certain things in the framework that it provides. One of these things being an example, the speed of light. Bachelard says about the speed of light, quote, "The speed of light is no longer appears as a reality found in an experiment, but rather as a reality affirmed in a rule." Another thing that happens, argues Bachelard, with the progress of science and with the development of scientific reason, is that you kind of have this dialectic in science, if you look back at the history of science, between scientific realism on the one hand, empirical observation, and instrumentalism or rationalism on the other hand. So there's always been this question, going back to Copernicus, about whether or not these theories merely mathematical descriptions of reality or reflection of how reality actually is. And what Bachelard says happens with, well, Bachelard traces it back to the early scientific revolution with Newton, but it's kind of exemplified in Einstein's theory of relativity, is that certain assumptions about reality are assumed on the basis of pure mathematics, one of these being the speed of light. That the assumption made by relativity is that the speed of light is constant when it moves from point A to point B. This is an issue because there's no way to measure that. That it's assumed within the context itself, but that these sorts of assumptions we have to accept if we're to accept the science of it. And another big influence is microphysics. Again, the same sort of challenging of basic notions. Microphysics, says Bachelard's, ambiguous phenomenon which never stand for our things. What's happening here? And then he goes on to say, we cannot increase our knowledge of an ultramicroscopic object by isolating it. Again, a sort of change in rationality insofar as previous to the development of microphysics, if you wanted to study, if you look back at like the history of alchemy and the early history of chemistry, the early experimental sciences were all about isolating an element and reducing that element to its purest form. What we see with microphysics is kind of an inversion of that, and the things that we talk about within the context of microphysics are not the same sort of things that we encounter in our day-to-day life. And that in fact, these things have to be placed within that larger context. Like I talked about with relativity, the speed of light is placed within that context in order to explain other things. It's the same with microparticles. Okay, so what the heck does any of this have to do with time. So as I was saying before, for Bachelard, science introduces new standards, new forms, new avenues of rationality that philosophers ought to abide by, that introduces new ways of thinking to philosophical discourse. And the primary example that we have in Bachelard's writing in which this takes place is his philosophy of time. So I've given kind of a general overview and talked about the two big influences, relativity and microphysics. I want to talk a little bit about the concrete example of how this relates to Bachelard's philosophy of time. What we have here kind of, and this is my argument, if you read other scholars who specialize in Bachelard, you may not find this really represented except for in the articles that I have published. But what we find here with at the heart, at the core of Bachelard's philosophy of time is an analogy to microphysics in order for Bachelard to explain what exactly he means by time. As I mentioned before, Bachelard has 2 works on the philosophy of time and several works on the philosophy of science. In one of his works on the philosophy of science, titled Space and Contemporary Physics, he talks about the implication specifically of microphysics, of quantum mechanics, and how it changes our understanding of basic concepts. So one of the things that Bachelard likes to point out with respect to science and with respect to how science changes rationality is how it changes our understanding of previously uncomplicated concepts. So for relativity, this was time and time dilation, simultaneity. What does it mean for 2 events to happen at the same time? Einstein cast fundamentally complicated this notion of simultaneity. Bachelard says that Heisenberg will do the same thing, but with place. It's commonly understood, if I ask you, where is something? Where is the cup of coffee? Where is the car? Right? This is a pretty concrete question that has a very simple answer. The cup of coffee is on my desk. It's right here at this particular place, right? I could point to it. I could diagram it if I was some kind of like psychopath or something. I don't know. Same with the car example. The issue here is that once you start talking about microparticles, particles that are only observable using microscope technology, that this gets incredibly more complicated. And with the introduction of Heisenberg's uncertainty principle, you can see why, that place and space isn't as exact as we once thought it was. Just as a brief refresher, and especially because there's a lot of misunderstanding surrounding what exactly the uncertainty principle is. But Heisenberg introduces the concept of the uncertainty principle in a paper that he wrote in the late 1920s. I think it's 27, 28. Heisenberg says, the title of the paper, if you're interested, it's kind of readable, just like Einstein's on the electrodynamics of moving bodies is readable even to the non-specialist. So if you're interested in the history of science, I encourage you to take a look at that. The paper's titled The Physical Content of Quantum Kinetics and Mechanics. The uncertainty principle refers to our ability or inability to measure the precise location of the electron in its orbit around the nucleus. Heisenberg says, and these are quotes from the paper, "At the instant when position is determined, therefore at the moment when the photon is scattered by the electron undergoes a discontinuous change in momentum. The more precisely the position of an electron is determined, the less precisely the momentum is known. And conversely, the more precisely the position of an electron is determined, the less precisely the momentum is known." So this is the observation that Heisenberg makes. So if we're trying to trace the momentum and the position of electron, especially if you're trying to like graph the position and the momentum of the electron around the nucleus, you run into a fundamental problem. That fundamental problem is a problem of measurement. So you have the measurement tool, the technology, the microscope, and you're trying to observe the electron. The issue here, so in order to, because of how our eyes work, I'm not as up to date on biology as I am on physics, right? But the reason why we're able to see what we see is because the reflection of photons. The issue is that the act of observation introduces the photons of light that's going to and from the electron. And because the electron is such a small particle, that photon will influence the momentum or the direction that the electron is going. So as a result, precise measurement is, on the quantum level, indeterminate. This is the indeterminacy thesis, is the idea that we can only know one or the other. The reason why we can only know one or the other is because of the type of technology that's employed to try to measure the momentum and the position of the electron. The introduction of the photon disturbs that in one way or the other. So when people say that the observer affects reality, if we're talking at a very, very specific level, this is what we're talking about. It's because of the interaction of the photon and the electron that the observer is affecting reality. It has nothing to do with our consciousness affecting reality. It's our means of observation is affecting reality, or is affecting the outcome of what we're trying to observe. So what does this have to do with time? Bachelard's position, again, in contrast to Bergson, Bergson presents time as represented in this concept of duration, that time has a flow, has a momentum to it. Bachelard calls Bergson's philosophy a philosophy of fullness. Our past has moved towards our future, and that lapse of time that has taken place between our birth and now is one of the things that we would identify as duration. Bachelard says that Heisenberg's uncertainty principle is analogous to what we see happening at our current conscious level with respect to time, in the sense that time is indeterminate in the same way our observations about the electron are indeterminate. What I mean by this is that instead of duration, Bachelard will argue for the instant. But when I'm talking about the instant, it would be a mistake within the context of Bachelard's philosophy of time to understand what he means by the instant as a brief moment of time, as opposed to an extended duration. So when he says instant, he's not talking about a quantifiable snippet of time. When Bachelard says that the reality of time is located in the instant, he's not saying that it's located between 0.001 second of conscious attention and 0.02 seconds of conscious attention, or whatever it is. It's not quantifiable per se, and in that respect, he would agree with Bergson's account that there's something unquantifiable about time. The instant is analogous to indeterminacy in the sense that the instant reveals our kind of this ontological gap in our understanding of time. There's only so far down we can go with respect to time. And the instant in this sense should not be thought of as a unit of measurement, but rather as a conscious act. This conscious act is instantiated in things like memory, our remembrance of time, or our current experience of the time of our lives. So the instant is discontinuous. So again, Bergson, we have the continuity of time, the flow of time, one sort of universal segment of time. For Bachelard, the instant is discontinuous, is broken up, is fragmented, because it's not immediately clear. And what Bachelard has in mind here, think more psychology rather than physics. The instant is broken up because it's not immediately clear how these instances relate to each other. In other words, Bachelard says that we're mistaken to think that the past is inevitably moving towards the future, or that the future is somehow predicted or predicated or already established, and that the present is moving towards the future. That this language gives us a misrepresentation of what time is. So these instances, these discrete instances, are not inherently or causally linked to one another. Rather, these instances emerge. We make sense of these instances because we put them in relation to each other, and we construct a narrative out of them. So that might sound very philosophical and very loaded with philosophical jargon. Another way to think of this, so Bachelard is taking the techniques and the implications of physics, and he is applying them to psychological implications. So what he is fundamentally saying is that our sense and nature of time is a rational construction of our brain. This has implications for things like narrative meaning. So again, going back to this more psychological question, if I were to ask you, who are you? Or if I were to ask you to, as a thought experiment, to tell me, what has your life meant thus far? Or what is the meaning of your life? How you would explain that, says Bachelard, is a rational construction, is a linking together of separate instances and moments in time, putting them into some sort of coherent narrative. But we would be mistaken to think that that narrative is somehow primary, which is Bachelard's big critique of Bergson. To use more philosophical language, another implication of this is to think that the self is primary, or that the soul is primary, that we have this innate self or soul that exists across time and space. Bachelard says that we can talk about the self so long as that we understand that the self is a rational construction that we build. And because we build it, and because of its constructive nature, this means that the self is changeable, it's mutable, and that our lives can veer off into new and distinct directions. So part of the metaphysical implications that Bachelard derives from the current scientific understanding of things like relativity and microphysics is this idea that time is not, that physics presents us with a sort of, if you've ever heard of the block universe, that physics presents us with this universe in which time is within the context of relativity, relative to the observer, that we all have and experience different sorts of time. The picture that physics presents of time is actually not so different from how we experience time. And that Bergson's mistake is to assume that our intuition reveals this sort of extended duration. Bachelard's just pointed out, yes, we do experience, as biological organisms, right? We do experience the flow of time, but we have to remember that this flow is not fundamental and is not an inherent aspect to our time, and that different people will experience different flows, and that the same individual throughout different points of their life might find ways to reinterpret, to reimagine that flow. So I hope that this video was educational in some way, shape, or form. I'll return to Bachelard's philosophy of time in a later video and unpack some of the more philosophical interpretations of what Bachelard has to say about time and why this is important for things like creativity, poetry, and music. All right, till next time, I'll see you all later.